We will start this module with a discussion on controllers, actions, and endpoints. Then we will talk about routing rules, which are what allows us to map endpoints with actions. Later, we will talk about the data types that an action can return. And we will talk about asynchronous programming. We will introduce model binding, model validation, dependency injection, and middleware. Then we will see the different types of filters that we can use, which will help us to have reusable code between different parts of the life cycle of an HTTP request. As you can see, we have a lot to talk about in this module, so let's get started right away. First, let's install Postman. In this video, we are going to install Postman. Postman is a powerful API client that will help us to consume our Web API application. In order to install Postman, we have to do the following. We have to come down here all the way to the bottom. Let's click on Download App, and I will click on Download App, and you can choose whatever Windows architecture you have. In my case, I already downloaded and installed it, Postman, so let's open it now. Here we have Postman, and if we want to do a small test, we can just go here. We can close this. Let's click on this plus sign, and here we have the request window. Here we can choose what kind of HTTP method we want to use. For example, we have get, post, put, patch, delete, and etc. We're going to do a get, and we're going to go to either Visual Studio or Visual Studio Code if you're using Visual Studio Code, and I want you to run the application. So in my case, I will press Ctrl F5. I will take this URL from here and I will paste it on Postman. And I want you to see something. I want you to see how ugly this looks here on Google Chrome. But if we go to Postman and we make a GET request to our URL, then we're going to get a more formatted version of our data. Here, as you can see, we have our date, temperature, and summary, all in different colors from their values and in different lines so that they are easier to read. And we have a lot more to see. For example, we can go to headers and we can see the HTTP request headers that were sent to the server, and we have here in the response section of Postman the HTTP response headers that we got. For example, we got that the content type is application JSON. That's because our data is indeed in JSON format. Before we start talking about the main content of this module, we are going to need some helper classes to work with. The first class that we're going to create is an entity for a genre. So what we're going to do is that we're going to create a folder here, add new folder, and we will create an entities folder, and we are going to right click on it and we're going to create a new class, which is going to be the genre class. This is going to serve to model a genre, a movie genre, like action, comedy, and so on. For now, it is just going to have two properties, which are going to be ID and name. The next thing that we need is a repository. Through a repository, we are going to serve instances of the genre class. The idea here is that we are going to save our genres in a database, and with a repository, we have a dedicated class to talk to the database, retrieve the genres, and return it to whatever client is using the repository. For now, we're going to use a fake repository, a repository in memory, because we're going to build our database in the next module. For now, we're just going to work with in-memory data. So what we're going to do is that we're going to create a new folder, and we will call it services. So let's come here and say services, and we're going to say new class, and we will call it in-memory repository, and we will press enter, and here we are going to create a constructor, and inside of this constructor we are going to initialize a list of genres. So let's say here private list genre, and we have to press Ctrl dot to bring the namespace movies API.entities, and then we are going to say genres, and we are going to say genres equal to new list, and we are going to initialize it with two genres by default. We are going to say comedy and action. Now we are going to create a method that is going to return our list of genres. So let's say public list of genres, get all genres, and we're going to return our list of genres. Now, how do we use this class? There are several ways to do that. One way would be to go to a controller, for example, weather forecast controller, although we're going to create our GenRAS controller in just a minute, but for now, let's make a test here. We could do the following. We could say var repository equal to new in-memory repository, and we could use the repository in this way. And although this may be fine, it is in general not a good practice to instantiate services in this way, because it makes our architecture not flexible enough to handle different implementations of a service. So what we can do is to, instead of having this here, we can inject it through the controller. We can say, just like we have an iLogger here, we can say in-memory repository, and we can initialize it as a field. Now we will have a field repository, and we can delete this. We can delete this line of code, and here we can use our repository, which is injected from the controller of our class. Nevertheless, even this is not enough flexibility in some cases. Sometimes we may wish to use an interface. We will talk more about dependency injection later in this module. But for now, we're going to create an interface. So let's say new item, interface. We're going to call it iRepository. We're going to make it public. Let's go to in-memory repository, and we're going to say that in-memory repository implements iRepository. And now we're going to come here to this public method. We're going to right-click it, quick actions and refactorings, and we want to pull get all GenRAS up to the iRepository. The idea here is that now this signature of this method is going to be listed inside of the interface. This way, every single class that implements the iRepository interface is going to be obligated to implement a method with this signature. Now, instead of using in-memory repository here, we can say iRepository, and now we have a flexible repository, which can be any class that implements the iRepository interface. We have to change this to iRepository, and now we have to configure our dependency injection system. Again, we're going to talk more about dependency injection later. For now, we just want some data to work with. So let's go to the Movies API project, to the startup class, and here we're going to have a configure services method, which allows us to configure services at singleton. Because this is going to be an in-memory repository, we're going to make it a singleton. But later we're going to change this to add scoped. Again, we're going to explain all of this later. And now we're going to say iRepository and in-memory repository. What this means is that whenever we get asked an iRepository service, we're going to serve, our dependency injection system is going to serve an in-memory repository instance. Therefore, although we're not going to use the iRepository from this controller, we can use it from our controller. So let's delete this. Now we're not going to use this controller. What we're going to do is that we're going to create our own controller. So let's come here and let's say new class, GenRAS controller. And from this controller, we are going to use our in-memory repository through the iRepository interface. So let's create a constructor, iRepository. Let's bring this namespace, repository, and let's initialize it as a field. And now from this controller, we're going to have access to the data from the in-memory repository. But what is a controller? And how do we configure it? We're going to see that next. The fundamental idea of having a web API is that we will have clients that will make HTTP requests to our web API. These HTTP requests are made to a set of URLs of our domain. We call these URLs endpoints of the web API. An endpoint then is where a resource resides. An example of an endpoint could be myapi.com/genras, where myapi.com is my domain and /genras indicate by its name some type of resource related to movie genres. Informally, one usually calls the previous endpoint /genras without needing to mention the entire domain. When we make an HTTP request to an endpoint of our web API, we typically want a method of a controller to be executed. We call this method an action. So, an action is a method of a controller that runs in response to an HTTP request made to our web API. Meanwhile, a controller is a class that groups together a set of actions. Typically, A controller groups actions that relate to a resource. Thus, in the case of our endpoint/genres, it is likely that we have a single controller which handles the actions related to this resource. By convention, controllers are named by concatenating a word, such as a name of a resource, with the word controller. Thus, a controller for genres can be called genres controller. These controllers are usually placed in a folder named controllers, although this is just a convention and you can put a controller wherever you want. As we saw in Module 1, we can use HTTP methods on a resource to manipulate it. In ASP.NET Core, this means that we can configure what action we want to run according to the endpoint and the HTTP method used by the user. In that sense, we can have a controller like the following. Here we have the controller that we created in the previous video. This is a genres controller, so we can assume that it is going to work with a genre resource. As we said, we can create methods in this controller that is going to respond to HTTP requests to our web API. In order to create one of those methods, we can do the following. We can say public and then the data type that we're going to return. What can we return? Well, whatever we want. One example will be a list of genres. So let's say list of genre, and we need to bring this namespace, and we can name this method also whatever we want. By convention, we can use get. This method may or may not have parameters. In our case, we're not going to have any parameters for now. So inside of the body of the method, we can do the following. We can say return repository. Remember that we're injecting the repository through the constructor of the class, and we're going to say dot get all genres. And with this, we are returning to the client of our web API all the genres that we have in our database, which right now is an in-memory database. Now, how can we specify to which HTTP method this method is going to respond? For that, we can use an HTTP attribute. So we can say HTTP, and we can write get. We can press Ctrl dot and we can bring this namespace Microsoft.ASP.NET Core.MVC. Another thing that we have to configure is what endpoint should the client use to communicate with this controller. For that, we can use a route attribute. Here we can say route, and we can define the endpoint of the controller. By convention, some web applications start every endpoint with API, something like API/something. In our case, we can say something like genres. So if we do an HTTP get to this endpoint, then we're going to execute this method that we have here. Let's make a test. Let's press Ctrl F5 to run our application. And by default, we're going to have weather forecast here, but we want to have API/genres, and as you can see, we have two genres which are comedy and action, which is exactly what we put on the repository class. Now let's go back here and let's continue working. Something else that you may see is to not have genres here, but to have this placeholder controller. This does the exact same as having genres here. What controller means is to automatically put here the name of the controller without the controller part. So in our case, it is genres. Some people advise against this because if at some point you change the name of genres controller, for example to genres2 controller, then this is going to be automatically changed to API/genres2, and every single client that uses your application is going to have to be updated. So if you want to avoid this, you can just write genres here and be done with it. So let's delete this and let's continue. As we know, besides HTTP GET, we have other methods like HTTP POST, HTTP PUT, and HTTP DELETE. Let's create methods for all of those cases. Let's start with HTTP POST. So let's say public. For now, we're just going to say void here, post, and we're just going to leave this empty. We're going to implement this in a moment. Now let's make the same for HTTP PUT and HTTP DELETE. HTTP DELETE, public void delete. Now, how do we know they work? How can we test these methods? For example, delete. Let's click on here. Let's put a breakpoint here. And what we're going to do is that we're going to run our application in debug mode. For that, you can come here to debug, start debugging, or just press F5. So let's press F5. And now let's do the following. I am going to copy this, and I am going to go to Postman, and let me create a new tab. and I will paste this, and I will say API genres, and if you press send, you are going to see that we get our two genres, but in our case, we want to issue a delete method, so let's say delete here, and let's click on send, and as you can see, we are indeed executing this method, which means that by using this attribute here, we are indicating what method we want to execute depending on the HTTP method used by the client. When we just say method, we're referring to a C# method, and when we say HTTP method, we're referring to things like HTTP delete or HTTP put. Now let's press Shift F5 and let's continue. Something else we may want to do is to allow the users to request a single genre. For example, let's say public genre get, and we're going to try to get a genre from the repository by its ID. Now, where are we going to get this ID? We have to receive it from the user, so we're going to say int ID. And now, as you can see, we're getting an error because we need to return a genre. So what we're going to do is that we're going to go to the in-memory repository. For that, we can do the following. We can say right-click on a repository and let's go to implementation, which is going to take us to the in-memory repository. Now let's go here and let's create a new method, which is going to be public genre get genre by ID, and let's pass an ID as a parameter, and let's say return genres where ID is equal to ID. Instead of using where, let's just use first or default, which is better, and let's put a semicolon here, and now let's right click here, and let's say quick actions and refactorings, and let's pull this method into the iRepository interface so that we can use it from here. Now let's say var genre equal to repository get genre by ID, and let's pass the ID, and let's return the genre. But what happens if the user passes an ID which has no corresponding genre? Well, in that case, we are going to get null here. And instead of just returning null, we want to return a 404. For that, we can do the following. We can say if genre equal to null, then we want to return a 404. But how do we do that? There are some helper methods for that. And in order to access them, we have to inherit from a class called controller base. Now let's put controller base here, and now we can say something like return not found. With return not found, we're saying that we want to return a 404. Now we have a problem here, and the problem is that here we have a genre, but this is not a genre. This is a not found result type. We're going to fix that later, so for now we're just going to comment it out. Now we want to make this usable by an HTTP GET, so let's say HTTP GET, and let's press Ctrl F5 to run our application, and we're going to get an exception when we go to API/genres. And the problem is the following. We have two methods in our genres controller class which can respond to a HTTP GET request. Now what the error is saying is that the request matches multiple endpoints. And because ASP.NET Core cannot decide which method to use, then we get an exception. So what can we do to correct this? For that, we need to use routing rules. We will see that next. Routing rules are a mechanism that allows us to map a URL with an action. That is to say that when we make an HTTP request to an endpoint, then we want to execute a certain action. In a Web API environment, we use extensively what's known as routing by attribute, in which we define the routing rules through attributes that are above a controller or an action. In other environments, like in MVC, we also can use conventional routing, in which we declare the routing in one place. Here in Web API, we are not allowed to do that because we are going to use another attribute which is called API controller, which requires you to use routing by attribute. The first thing we notice in a controller when we visualize it is the route attribute. The route attribute allows us to indicate the base or prefix of the endpoints of the actions of the controller. This means that by default, all the actions of the controller will have an endpoint that begins with the one indicated in the route attribute. In our case, in the genres controller, that prefix is API/genres. We can also define the endpoint of specific actions by passing a string to the HTTP method indicator. For example, to HTTP GET, we can pass a parameter that will indicate the endpoint of said action. Now with this, we can solve the problem that we had in the previous video. Let's go to Visual Studio. We are in Visual Studio, and we remember that our problem is that we have two methods in our GenRAS controller that can handle an HTTP GET method. But what we want is to alter the routing rule of one of these methods so that they are different from each other. What we can do here is that we can open a parenthesis, and as you can see, we can pass a template. With this template, I can write something like example, and that is going to alter the routing rule of this action in the following manner. If we go up, you are going to see that we have a route attribute here, which is API/GenRAS, and we have example here. What is going to happen is called a combination. This HTTP GET, this template here, is going to be combined with the parameter of the route attribute. Therefore, the final endpoint of this action is going to be API/GenRAS, which comes from the route attribute from the controller, plus /example, which comes from the HTTP GET, which means that now this endpoint here is just API/GenRAS because it inherits that value from the route attribute, and here we have API/GenRAS/example, which means that now these two have different endpoints, and therefore we have fixed our issue. Though we have now another problem, and it is from where is this ID coming from? Let's make a test. Let's try to do a GET request to this URL. So let's make a test. Let's press Ctrl F5 to run our application. And what we're going to do is that we're going to go to Postman, and we're going to paste the URL API/GenRAS/example send, and it says 204, but we're not getting anything back. Why is that? That is because by default this value is 0. So how can we pass a value to it, like 1 or 2, which are valid IDs from our GenRAS repository? Well, for that we have two options. The first one is to use a query string. For example, let's go back here and let's say interrogation sign ID equal to 2, for example. And as you can see, Postman is really helpful because here in params we get a list of all the parameters that we have in the URL. So if I want to modify this, I don't have to do it through the URL. I can just come here and put a 1, and it is going to automatically update the URL. So let's press send, and here we are getting back the comedy genre. And if we do 2, if we go and say 2, and we press send, we have action, which is great. Another option is to use a route value. Instead of having /example, I want to have /1 or /2, and I want that 2 or 1 to be passed in as a parameter to this method that we have here. We can certainly do that by using the following syntax. Instead of putting a string here, we can put a placeholder using curly brackets. For example, we can say curly brackets ID. And now that says that there is going to be a combination between API/GenRAS and this value here. But this value here is not a static string like example, but it is a placeholder for a value which can be 1, 2, 3, 4, 5, or whatever number we want. So let's make a test. Let's press Ctrl+Shift+V to compile the application, and now we can go back to Postman and we can make a test here. Let's change this for 1, and as you can see, we are not using a query string but a route parameter, and let's press send, and as you can see, we again have comedy. Something else you can do is to give more than one endpoint to a method. For example, instead of having just HTTP GET here, we can say HTTP GET again, but now we can pass a template. For example, we can say list. Now let's compile the application, and let's see that now if I go back here and I remove this, we're going to get the whole list of GenRAS, and if I write /list and we press send again, now we're getting the exact same list, which means that we're executing the same method through these two different endpoints. Something else we can do is to not use a combination, but to override the value in the route parameter. We can do that by starting the template string with a slash. For example, let's say HTTP GET, and let's just say all GenRAS. And because I started this value with an slash, now this overwrites whatever we have here, so the endpoint here is all genres. Let's make a test. Let's compile the application. Let's go back to Postman and let's delete this and let's say all genres and let's press send. And as you can see, we again have the list of genres. We are not limited to have only one parameter in the URL. We can have several parameters. For example, let's go back to Visual Studio and let's say that we want to have a second parameter like param2. Now we can put it in the URL like this. As a route parameter, I can say param2. And what if I want to have a default value for this parameter? We can certainly do that by saying equal to, and let's say Felipe. And now let's put a breakpoint here and let's make a test. Let's press F5 to run in debugging mode. And now let's go here to Postman and let's say API/genres/2. And here, as you can see, we have that param2 is equal to Felipe. And now if I press F5 and I say /scat, let's press send. And we have that param2 is equal to scat. And let's press F5. Now, what happens if instead of sending a numeric ID like 2, we send something like hammer? And let's press send and see what happened. We see that ID is equal to 0, which may or may not be what you want. So let's press F5 and we're going to see that we don't get any result. So we have two problems. The first problem is that the request is going through the method by passing an ID equal to hammer, which is incorrect. And the second thing is that we are getting a 204 no content when what we should get is a 404 because the resource was not found. Let's fix the first issue. Let's go to Visual Studio, let's press Shift F5 and let's use a route constraint. With a route constraint we can define the specific data type of a parameter. So here I can say int and that's it. Now if I press F5 and try to make the same request, let's go here, let's press send. And now we're getting a 404, but we're getting a 404 because we're not entering into this method because this route constraint wasn't respected. But we remember that if we pass an ID like 0, for example, let's go back here and let's say ID equal to 0 or 3, let's press send, we go through, the genre is null, but we're not being able to return not found, and that is why we're not returning a 404 here, but a 204. What we have to do to fix this issue and being able to return a 404 from this method is to talk about the data types that we're allowed to return from an action. We will see that next. From an action, we typically return the following: either a specific type, an action result of T, or an iAction result. We're going to explore these three options. However, first I want to talk about action result. Action result is a class that represents all type of data that can be returned from an action. It is literally the result of running an action. There are classes derived from action result which we can use to indicate that we want to return a specific data type. For example, if we have an action that we always want a JSON to return, we could use the JSON result class. However, instead of using action result as such, we usually use other options. The most common are action result of T and iAction result. Let's start by looking at the simplest return type, the specific type. This is the one that we have been using. Here, as you can see, we have a get method which returns a list of genres, and here we have a get method which returns a single genre by its ID. Now, the problem with this approach is that it is inflexible, because as we can see, if we try to return a 404 for when we cannot find the genre, we're getting an error, because we cannot return a not found result when we're supposed to return a genre. So instead of returning a specific type, what we can do is to return an action result of T. The action result of T allows us to return a specific type or an action result. The specific type that we can return from an action result of T is the T type. For example, instead of saying genre here, we can say action result of T, so we can use generics, and now we're not getting any errors. Why? Because with this, we're saying that we want to return either a genre, which is what we're returning here, or an action result, which is what we're returning here, because not found result inherits from action result. So with this we have fixed our issue. And we can do the same here if we want. We can say action result of list of genre. And we can do the same in all the other methods that we have in our genres controller class. We can say here action result here, and action result here. Now for now these methods are not returning anything. So what we're going to do is that we're just going to say no content in each of them, but we're going to fix them later. Another flexible option besides action result of t is iAction result. With iAction result, we can return any kind of action result. For example, we can say iAction result, and as you can see, we're not getting any errors here in not found, but we're getting one error here in genre. To fix this, we have to say OK. OK, which means a 200 OK, and here we are passing the genre as a parameter. So the genre is going to be returned as part of the body of the response. So which one should you use? Action result of t or iAction result? In general, prefer action result because with this you can define the specific type that you want to return. Here in iAction result we can return whatever type we want. We can say return OK a number or return OK Felipe or whatever we want. As you can see, we are not getting any errors here because as long as we use OK, there is no problem. But with action result of t, in this case of genre, then although we don't get an error here, it is because we are using OK, and if we drop the OK and we drop it here, you can see that we're getting an error with Felipe because Felipe is a string. So if we comment this out and we return genre only, then we're not getting any errors. So this way, we're making sure that we are either returning a genre or an action result from this method. Also, keep in mind that action result of t was introduced in ASP.NET Core 2.1. Therefore, if you have to give support to a ASP.NET Core 2.0 or any older version of ASP.NET Core, you are only going to be able to use iAction result. An action can be synchronous or asynchronous. All the examples we have seen so far have been synchronous actions. Let's see an example of an asynchronous action. However, first let's review what does asynchronous means. Let's see an analogy. Suppose you ordered a pizza through your phone to have it delivered on your home. They tell you that's going to take 30 minutes. What do you do in those 30 minutes? Do you just freeze right there, waiting for the pizza? Or do you do some other task around the house while the pizza arrives? It is a no-brainer that you want to make the most out of your time. So you decide to do some stuff while waiting for the pizza. Common sense. Something similar happens when we make an asynchronous action. We allow that while this function is running, our web server, instead of waiting for it to finish, better start doing other tasks in the meantime. However, it is important to note that we do not always want to do all of our functions asynchronous, since nothing is free in programming, and doing an asynchronous action has a small cost of performance. In general, if you will do operations with databases or you will communicate with other web services, then it is worth doing an asynchronous action. To make a method asynchronous, we decorate it with the async keyword. And the return data type must be task something, where something in our case will typically be an action result of t or an iAction result. Let's see an example of this. Now let's see an example on our application. We know that we have a repository, but this repository works with a memory implementation of a list of genres. Therefore, we don't really need asynchronous programming in our case, but in the next module, we are going to use a real database on SQL Server by using Entity Framework Core. So what we're going to do, just to practice, is to make this method asynchronous. Get all genres. So, as we said, to make it asynchronous, we decorate it with the async keyword here, and we also need to have the return type to be a task of t. So we say task of list of genres. This means that in the future, this method is going to return a list of genres. So that's why we have to put it inside a task. So what we're going to do, just to not have this here, we're going to say await task delay and we're going to say 1 millisecond. And the idea here is that now this method is asynchronous, and we're waiting for this delay, and for that we're saying await. This await is like what I just told you about the pizza. Since we're saying await this, let's pretend for a moment that this is going to be 3 seconds. This await means that the web server can handle any request that it wants, and that in 3 seconds it is going to come back here, and then it is going to continue the execution of our getAllGenres method. Now what we need to do is to update our iRepository, since this now returns a task of T. So let's go here and let's say task of list genre, and now let's go to genre controller, and as you can see we have here that we need to return a task of T, and this is something that you are going to see every time you use asynchronous programming, and it is that you have to do asynchronous programming in every single layer of your application. So as you saw, we use asynchronous programming here in our repository, and that means that every single client of our repository should use asynchronous programming. Do not mix synchronous and asynchronous programming, because you are going to get nasty errors in production. So now that we have task here, we have to make this asynchronous because we want to await this also. And as you can see, we don't have any more errors. Now we are awaiting our call to the repository. Now let's make Control F5 to run the application, and let's make a test. Let's go to Postman, and let's delete these 3, and let's make a request here. And as you can see, the request took about 3 seconds. That is because our task delay. Now if we go here and we put, instead of 3 seconds, just 1 millisecond, and we compile the application, we can go back to Postman, send the request, and now we can see that it only took about 500 milliseconds to process the request. And if I click again, you can see that now that the application has warmed up, now it took less than 20 milliseconds. Again, asynchronous programming is the way to go when we use database access technologies like Entity Framework, Dapper, or ASP.NET, or when we talk with another web service. By using async in the right places, you have scaled up your application because it can now process more requests with the same resources.